Hello students, we'll start today with Maxima and Minima, one of the most important topics for your 12th standard, be it CBSE board, ISC or state board. We begin with Maxima, Minima. Look at these 4 points P, Q, R, S. As you are seeing, they are the turning points क्योंकि ग्राफ उस मोमेंट पे टर्न कर रहा है. वैसे S के बाद ग्राफ इनफाइनाइटली ऊपर जा रहा है और P के पहले it is going infinitely down. So we are unable to know what is the maximum value or the minimum value before P and maximum after S. So these points P and R are called maxima, but we allow or we place a word called as local maxima, while points Q and S are similarly called local minima. ये जो पॉइंट S के बाद ऊपर तक कहीं पे तो एक मैक्सिमा आएगा इज कॉल्ड ग्लोबल मैक्सिमा, एंड P के पहले जो कहीं पे तो एक नीचे मिनिमा होगा इज कॉल्ड ग्लोबल मिनिमा. दो हमारी पढ़ाई यूजुअली लोकल में ही होती है. नाउ लुक एट पॉइंट्स P एंड R. इफ यू ड्रॉ अ टेंजेंट टू पॉइंट P और R or Q or S, you are realizing that its slope dy upon dx will be 0 because x-axis को चारों tangent parallel होंगे and x-axis का slope 0 है. So the first condition, be it local maxima or local minima, हमारा first derivative हमेशा 0 ही होगा at that instant. Now look at point P के just पहले and imagine we drawing a tangent at that point. This angle made by the tangent with x-axis theta would be less than 90 and more than 0, and therefore we can say dy upon dx is going to be positive for the points which are before P, as acute angle में tan positive value देता है. Now look at a point which is taken after P. Imagine we drawing a tangent here and the angle seen here is obtuse, which clearly means that dy upon dx will be negative here. So point P is sandwiched is between 2 points where before dy by dx was positive, at point P dy by dx is 0, while after point P it is negative. So for maxima, the derivative sign changes from positive to negative. That is what we call first derivative test. So for the first derivative test, dy upon dx को 0 होगा. उन points को हम बोलते हैं turning points या stationary points. For maxima, dy by dx को तो 0 होना ही है, but dy by dx की sign change होगी from positive to negative, जैसे points P and R पे हमने ऊपर देखा. And for minimum, dy by dx equal to 0 तो होगा ही, but dy by dx की साइन पहले and बाद में will be from negative to positive, जैसे हमने points Q and S में देखा. Now we are going to start with second derivative test. अब कोई भी फंक्शन अगर इंक्रीजिंग नेचर का हो, एक बार फिर से इंक्रीजिंग नेचर का हो, then its derivative is greater than 0. ये हमने इंक्रीजिंग डिक्रीजिंग फंक्शन में पढ़ा है. एक बार फिर से, if any function is increasing, then its derivative is greater than 0. If it is a decreasing, its derivative is less than 0. We begin now with one more way to find maxima and minima, which is called as second derivative test. Now, in the earlier point, if you can recall, for the point P, the sign was changing from positive to negative, and वहां पे हमें maxima मिला था. इसका ये मतलब है कि जो डेरिवेटिव है dy by dx वो डिक्रीज हो रहा है because it is changing from plus to minus. अगर dy by dx is decreasing, then its derivative is less than 0. But when dy by dx sign was changing from plus to minus, you had encountered a maxima. Therefore, for maximum, d square y by dx square is less than 0. Similarly, for a point say R, which we saw before, the sign was changing for dy by dx from negative to positive. Clearly dy by dx looks as if it's increasing. If it's increasing, then its a derivative, dy by dx derivative, will be greater than 0. Hence we get the condition that for maximum point, first derivative is equal to 0, but the second derivative is less than 0. Similarly, for point of minimum, first derivative is equal to 0, as you had seen it in first derivative test also, but the second order derivative d2y by dx2 is greater than 0. We should remember this condition for solving of problems. We now take our attention to points of inflection. There can be certain situations when dy by dx sign does not change. For example, let us look at point B, and when you draw a tangent to it, it is seen parallel to x-axis. Now let us consider a point which is little before B, say here, and you draw a tangent. This angle is acute. You take a point after B and you draw a tangent. This angle is also acute. We realize that the derivative sign is not changing from plus to minus. As both angles are acute, we understand that the sign in both cases for dy by dx is positive. Same way, if you would have taken a point after B and drawn a tangent, then it would have formed an obtuse angle, and a point after B here would have also formed an obtuse angle for us, indicating that at both places the derivative would have been negative. So for point B in both cases, the sign of dy by dx is not changing. Such a point, such a situation is called as inflection. So for inflection, in mathematical terms, as every time you may not be able to solve graphically, dy upon dx is equal to 0, that is the first condition, but d square y by dx square is also equal to 0, which means it is neither maxima nor minima, and the third order derivative should be not equal to 0. It could be positive or negative, but it should be non-zero. Let's take an example. Say we write y is equal to x cube. Its first derivative, dy upon dx, is equal to 3x square, and let us say we are looking at the point x is equal to 0. So let's remove this. First let's write is equal to 0, and then on solving this you get x is equal to 0. Then you take second derivative test, d2y upon dx2, which will be 6x, but x has already come as 0. When you put it here you get a 0, so second derivative is equal to 0. When you take the third derivative, d cube y upon dx cube, you get 6, which is positive or negative. What it is positive, so that's what we are saying, that d cube y by dx cube should not be equal to 0. Hence, for the curve y equal to x cube, its point of inflection is at x is equal to 0. We have also written here further that for all odd differential coefficient, means derivative of third order, is in favor of point of inflection if this value of odd differential is non-zero, like in this example it was 6, and it is in favor, so the answer would come in the form of maximum or minimum depending on the sign of even differential coefficient. So second order, if it is less than 0 then maxima, if it is more than 0 then it is minima. Let's start with some questions. Taking up the first one. Examine the function y equal to x minus 3 raised to 5 x plus 1 whole raised to 2 for maxima and minima. एक्सपांशन तो हम करने से रहे 5th डिग्री है. Let us name the function as y is equal to. जब भी क्वेश्चन मैक्सिमा मिनिमा का आ जाता है, let us take derivative and equate that derivative to 0. So by product rule of derivative, let us integrate first term phi into x minus 3 raised to 4 into derivative of x minus 3 is 1 into x plus 1 raised to 2 plus x minus 3 raised to 5 into derivative of x plus 1 whole square is 2x plus 1 raised to 1 into derivative of x plus 1 is 1. We equate this to 0. Recall first order derivative. You know why we equate it to 0. Let us take common. X minus 3 the whole raised to 4. X plus 1 is common. We are left with 5 times x plus 1 remaining, which is 5x plus 5. We are multiplying 5 with x plus 1 plus 2 times 1 of the x minus 3 is remaining to be multiplied because fourth degree is taken out common. So we write here 2x minus 6 is equal to 0. This gives us x minus 3 raised to 4, x plus 1, 7x minus 1, 5x plus 2x, 5 minus 6 is minus 1 equal to 0. Clearly the turning points, or it could be inflection, we do not know, but the critical points that we are getting is x is equal to 3, minus 1 and 1 upon 7. Now to solve further, we have two choices. Either we use first derivative test or the second one. But taking the derivative of this quantity is complicated. So we would prefer to instead go with first derivative test. Let us consider a value little less than 3. Let x be imagined as say 2.9. Then dy by dx will become equal to, put that value that you have assumed in this place. So if you put 2.9 minus 3 here, 2.9 minus 3, it is negative number, but raised to 4 means you will get a positive sign. Then 2.9 plus 1 is again a positive value. And 7 into 2.9 minus 1 is also positive. When positives are multiplying, you yield a positive only. Now let us consider x as 3.1, a little more than 3. We get dy upon dx is equal to, again you put x here as 3.1, minus 3 raised to 4 is positive only. 3.1 plus 1 is positive only, and 7 into 3.1 minus 1 is also positive, which is equal to positive, 3 times multiplying. So the sign of first derivative is not changing, hence we get x is equal to 3 is point of inflection, as there was no change of sign for first derivative. Let us now take our attention to minus 1. Earlier we talked about 3. Now let's take a value little less than minus 1. Let x is equal to minus 1.1. So dy upon dx is equal to minus 1.1 minus 3 raised to 4 is positive. Minus 1.1 plus 1 is negative. 7 into minus 1.1 minus 1 is also negative. Positive, negative, negative is positive. Let us now take a value little more than minus 1, say minus 0.9. dy upon dx would be equal to minus 0.9 minus 3 raised to 4 is positive, even degree. Minus 0.9 plus 1 is positive. Minus 0.9 into 7 minus 1 is negative. We get a negative answer. We realize that derivative sign is changing from positive to. So at x is equal to minus 1, we get a maxima as the derivative sign changes from plus to minus. For maximum value, we should substitute minus 1 in the given question. So when you substitute minus 1 here, this will become 0 and so will the entire value of y be 0. Hence maximum value is 0. We are left with now one last turning value. Let x is equal to 1 upon 7. Let us consider a value little less than 1 upon 7. So dy by dx is equal to, first part will be positive only because it was raised to 4th degree. The second part will also be positive as it is 1 by 7 is positive only, though you are taking a value little less than 1 by 7, and plus 1 plus 1 here will keep it positive. And when you have x here as one little value less than 1 by 7, then 7 cancels and this value is little less than 1, minus 1 will give a negative value. So here we get a negative value which is minus. At the same time, let x is equal to 1 upon 7, say thoda bada value. If you take a little bigger value, then dy upon dx becomes equal to, first is positive, second will also be positive, while third this time will also be positive. 1 by 7, say thoda bada value will yield a positive value in the last part, hence a positive. So the derivative sign is changing from negative to positive. Hence we conclude that we will be getting a minima at x is equal to 1 upon 7. And to get this minimum value, we have to substitute 1 upon 7 in the given question, which is 1 upon 7 minus 3 raised to 5. So 1 upon 7 minus 3 raised to 5 into 1 upon 7 plus 1 raised to 2. So this is clearly minus 20, which is 2 square into 5 upon 7, the whole raised to 5, times 8 by 7 is 2 cube upon 7 raised to 2. We can end the answer by writing minus 2 raised to 2 5s are 10 and 3 2s are 6, so it is 16 into 5 raised to 5, the whole upon 7 raised to 5, and 7 raised to 2 is 7 raised to 7. So this is the minimum value.